Hi guys, this is Avionics time, and today I would like to talk with you about compact position report. We will cover only the basic information about CPR, how we usually called it. First of all, we will talk about coordinates of user location. It may be referred to any sort of users. It may be aircraft, it may be some ship, or it may be car or vehicle, any vehicle. As you know, on board of any vehicle nowadays we have some positioning system, and in most cases it is GNSS, which is Global Navigation Satellite System. We use multi-constellation approach and we count our coordinates based on multiple constellation, and it makes possible to get accuracy up to 1 meter. However, transferring of this data is not easy. As we know, we have latitude and longitude, and if it is possible, altitude, and 3 of these parameters we need to transfer from on board to ground or to other vehicles, and during the transferring, if we send all the sequence of data, it will not be good, because latitude and longitude, it's quite long numbers. That's why we need to think how we can pack our coordinates to make it more short size. Another case when we can use CPR, it is archiving the data, because it's also not a good idea to store coordinates of user as we can see it in latitude, longitude and altitude, because it requires a lot of space in our hardware. That's why much more better will be to pack coordinates to more compact form and then store it in compact form. If we consider a quite simple example, like application in our mobile phone, which use receiver of GNSS, which installed inside of our smartphone installation. That's why I can navigate for some GNSS application, and you can see that this application can give us coordinates of our location, and in my case it is latitude and longitude, and most GNSS receivers like chip 1 give us coordinates in one of possible format, and one of them is just fraction of degrees. That's why, for example, 50, then dot, and then 5 or 6 digits after the point. That's why the same we have for longitude. That's why you see that actually our coordinates, it is 8 or 9 digits. That's why for storing this data we need to localize a place for storing 9 digits for latitude, 9 digits for longitude, and some amount of digits for altitude. That's why this is quite a long number for storing in our surveillance database. That's why it's not a good idea to store it like we have. Another reason to do that, if we consider our Earth. Okay, everyone knows that Earth is quite big, and vehicles that we have in our reality. It is vehicles which can move with quite low speed related to the size of our Earth. That's why in 1 second we cannot jump from Europe to Africa or to America. That's why there is no need to store all coordinates as we have, because each step we cannot jump for such kind of big size. That's why it is a good idea to localize a small rectangle where we are, and then mount like a small reference frame and make counting our coordinates within this small reference frame. And it gives us a huge advantage because we do not need to store the data with a global scale of latitude and longitude. Why? Because we do not need to use it during one movement of vehicle. Of course, if you talk about transatlantic flight, aircraft can take off from Europe and then goes to New York, for example. And this is quite a huge distance. And in this case, we need to use multiple local scales to catch our trajectory. However, compact position report, it is quite good to store and to transmit the data in compact form. Okay. First of all, let's try to understand what is CPR. Thus, CPR, or compact position report, it is a specific codding which helps us to reduce a size for our coordinates, latitude and longitude. Or it can be applied for any sort of data. And quite important also that this report can be scaled to any size of bits which we have for storing our data. Thus, first of all, CPR we can use for any sort of data or parameters. We can consider latitude, longitude, altitude, speed, heading, angle of attack, pitch, roll, yaw, and all other parameters which we have on board. However, we need to know that coordinates, latitude, longitude, and altitude play an important role. Because, for example, velocity and acceleration we can recalculate from the sequence of coordinates. That's why coordinates quite important. Reasons to apply compact position report. First of all, you know that our vehicles cannot fly so speedy or cannot move so speedy if you talk about ground. And in this case, we cannot jump in 1 second or in one step for very valuable distances. That's why there is no reason to use global scale of latitude and longitude for tracking of one object or one vehicle in the space. Because usually trajectory of vehicle is a sequential and will be jump from one point to another, which is located within the small vicinity. Of course, if you talk about global scale of our globe, of our Earth. That's why the main idea of CPR is just to localize a small frame, then locate in this frame small reference system, coordinate system, and then transform our latitude and longitude to small local reference frame. However, we transform it not like directly like we use in coordinate system transformation. We like code because we change scale of our measurements from latitude and from latitude longitude in degrees to some numbers like rulers in our reference frame. Okay. First of all, let me memorize you what does it mean, latitude and longitude. First of all, latitude. Latitude is an angle between line connected with user and equatorial plane. Thus, if we can cut our planet by equator, we can see equatorial plane. This is this one. And our latitude, it is an angle between equatorial plane and a line which connects user location at the Earth's surface and center of our planet. In this case, it will be a geocentrical latitude. However, we have another sort of latitude which is called geodetic latitude. And geodetic altitude, in geodetic latitude, this line, it will be normal to the ellipsoidal surface of our planet. And in this case, of course, we cannot reach center of our planet. That's why in this case, this line will be much more shorter than geocentrical line. Thus, we have two sorts of latitude, geocentrical and geodetic. Also, quite important that latitude scale is divided into two zones. First zone, it is north zone, and the next one, it is south zone. And at equatorial plane, our latitude is equal to 0. North side of latitude is marked with the sign plus, and south side of latitude is marked with minus. Thus we have minus 90 degrees of south latitude, then goes to equator, it will be less, and then we've got 0 latitude, and then we will have plus side of latitude, and at North Pole we have plus 90 degrees of north latitude. Thus, north it means plus, south it means minus latitude. Lines of constant latitude give us parallels. Thus, parallels, it will be lines of constant latitude, and in 3D space these lines will be represented as circles, because these circles, it is like a result of cutting of our Earth parallel to the equatorial plane. Thus, latitude give us parallels. Longitude is also angle, and in this case this angle is counted from a plane of prime meridian. Okay, thus many years ago scientists decide to use prime meridian like a 0 longitude meridian. That's why this line gives us 0. Thus, if we can cut our planet by this meridian, we get prime meridian plane. And angle longitude is counted beginning from this plane up to the plane in which we have our meridian of our location. That's why if we are located at this point, then we can use meridian which goes through our location and it creates another plane. Thus, angle between two of these planes give us longitude. And for both types, geocentrical and geodetic, we have one longitude. In this case, longitude divide our planet into two hemispheres. First one, it will be west hemisphere. It will be at the left side of our prime meridian, and east side, which is right side from prime meridian. And within each side we have a range for longitude from 0 to 180. Thus, for west side, we have from 0 to minus 180 degrees of west longitude. And for east side, we have from 0 at prime meridian up to 180 degrees of east longitude. And 0 will be at prime meridian level. Lines of constant longitude called meridians. Thus, meridians just connect North Pole and South Pole. Okay, let's go next. And the size of latitude from 90 degrees up to plus 90 degrees. For longitude, the same from minus 180 up to 180, which in total give us 360. However, during the reporting we can use just additional bit to put as sign of particular value. That's why we can use 180, because one bit of information we can use for minus or plus sign. That's why you see, if we use GNSS, it gives us 3 digits of longitude or latitude. It will be 2 digits. Then we need to use point, and then 5 or 6 digits with numbers. North, west, latitude and longitudes. That's why we can specify the maximum value of longitude at the 179 dot and 5 or 6 9 digits. And if we try to code it with just simple binary code, you will see that we need at least 25 bits of information. That's why we need to count logarithm with base of 2 from numbers which we would like to code. That's why in this case we require at least 25 bits of place to put longitude in communication channel or in the storing equipment. And this is not a good idea because this is huge amount of data. And CPR help us to make this space of bits less. In our talking today, we discuss only automatic dependent surveillance broadcasts because ADS-B concept is based on 1090 extended squitter mode, transmit current location of each airspace user, and everyone can get this data. And ADS-B uses CPR or compact position reporting approach to save a space in digital message, which is transmitted from on board of aircraft. And in this case, we divide the whole volume of latitude and longitude into specific rectangles. And for ADS-B, we use 60 layers of latitude. These layers, it's like rings around our planet. And length of each ring will be different because we've got a globe form or ellipsoidal form. And it means that ring at their pole has quite short range. However, ring at equatorial plane has quite valuable size. That's why, based on the size, longitude can be divided with a different amount of rectangles. That's why each layer or each ring of latitude includes different number of longitude zones. And here you can see that at the equatorial plane we have also 60 longitude zone. However, at the pole we have only one longitude zone because it will be like a circle, small circle. Then we have 2, 3, 4, 5, and then goes to 60. CPR consider using a specific coding of latitude and longitude within each small rectangle of latitude and longitude. If we zoom a little bit for Europe and we just choose one of the rectangles like this one, you will see. Thus, the main idea of CPR grounds on transforming our latitude and longitude to local reference frame associated with rectangle, this blue rectangle. That's why we use latitude, longitude and just recalculate it to reference frame of this rectangle. However, we have a specific scale of this rectangle. And this scale is grounded on a size of bits which we have for data transferring or for data storing. If we have 17 bits of data, that's why we just make a maximum number of one side of our rectangle to power 17. That's why this scale will begin at 0 and finish 2 power 17. The same for longitude. That's why the main idea, we need to transform latitude and longitude to particular numbers based on local reference frame of particular rectangle. And then this latitude and longitude coded at these numbers we use as CPR code. If you can see more carefully here, you will see that we do not need to transfer address of this rectangle. That's why we just recalculate our latitude and longitude to local reference frame and then transmit coordinates in local reference frame. And we do not need to transfer address of this rectangle. Why? Because we can easily recover. And there are two basic approaches. First approach is grounded on if we know previous coordinates of location. That's why if you know that we are located at this rectangle, it means that next time we also will be in this rectangle. However, if we will be at some boundary line of another rectangle, it means that when we count our next coordinates, we need to take into account that previous time we've been at another rectangle. That's why now we need to jump for next rectangle. That's why if you know previous coordinates, we can easily get our current coordinates. And we do not need to know any address of this rectangle in the global scale. However, if we do not have previous coordinates, in this case we use another approach. We use different size of layers. For latitude zones, we use two types of zones. First type is based on division of latitude space into 60 layers, and another size -1, 59. And we do the same for longitude. And then how we can get our coordinates? In this case, we need to receive transmission from both division for type of 60 degrees for 60 zones and for case of 59 zones. And then we just need to recalculate by specific formulas our location. And we've got coordinates of location within each rectangle. And then if you put it inside of like global scale, we can count distance between two of these points. And only in rectangle where we are, we have this distance minimal. Because for all other rectangles around the world, this distance will be higher than in rectangle where we are. That's why for rectangle where we are, we've got minimal distance between points from division by 60 layers and from point obtained by division in 59 layers of latitude and longitude. That's why even if we don't have our previous coordinates, we can obtain our coordinates based on two types of scaling in CPR. And it means that each time we need to transmit data in different scale. One time we transmit in scale 60 layers, another time we need to transmit in 59. And then we repeat in cycle 60, 59, 60, 59, 60, 59. And then algorithm try to catch the data and then process it based on available data in system buffer. And time for formulas. You think that it is quite complicated, however, it is not. That's why, for example, coded latitude we can count by this not very complicated formula. And to do that, we need to know the size of latitude zones. That's why it will be delta latitude, which we count like 360 divided by 60. However, we need to take into account that there are two layers, 60 and 59. And in my formulas, we have 0 for 60 size of layers and 1 for 59. That's why I here it's like a binary matrix which identify a layer type 60 or 59. Then if we have delta latitude, we can count our coded latitude by this formula, where function mod it is a function which returns the remainder after division of one argument by another argument. And floor it is a function for rounding input value to the nearest integer less than or equal to our value. That's why we use floor to make a rounding process. And inside of this one we have 2 power of n. N it is number of bits which we have for coding of our latitude and longitude. However, here I've got a mistake. That's why here it should be not 17, it should be n as well. For longitude, the same formula. You see that it is the same idea for longitude. However, size of longitude zone will be different based on latitude layer. That's why here we need to count latitude zone number. It means how many longitude zone we have at particular latitude layer. It can be counted by these formulas and then used in delta longitude, which will be different for each also latitude layer. And then we use delta longitude for counting our coded longitude. That's why applying two quite simple formulas, we can easily get coded values within our small rectangle. And this is the main idea of CPR. That's all for today, guys. Thank you very much for watching. Hope to see you next time. And please remember that CPR is quite important. And of course, we see latitude and longitude. However, in technical side, using latitude and longitude, is quite complicated because it requires a lot of space for storing geolocation data. That's why usually we transform everything in compact form. And CPR, it is a quite good idea to pack our geolocation data in small size without losing the data. And other important advantage of CPR, it will be automatically tuned to the number of bits which we have. That's why if we have, for example, 16 or 17 bits, however, our coordinates, latitude and longitude, is much more precise. For example, we have 9 digits after point, or after comma, in latitude or longitude, it doesn't matter. And in this case, this algorithm automatically scale or reduce performance of our latitude and longitude to make possible to code it with CPR. That's why CPR is dynamically tuning coding, which make possible to code to particular scale which we have for bits of data. Okay, that's all for today. Thank you for watching. Hope to see you again. Bye.